Okay, so in this video, we're going to talk about counting atoms by the grams. So I have here on the board part of my molar map, and I also have two examples I will work to help you understand how we figured it out in the number of particles or atoms in certain amount of grams. So for example 1, I have 0.5H3 grams of magnesium, and the question is how many atoms we have in this specific amount of grams, 0.5H3. Well, in order to calculate this, we needed to understand how our molar map works. I have part of my molar map here. So I have volume and mass. I know that volume and mass are related by density. So when I'm having volume involved in my calculation, I can figure it out the mass of my specific element by using the density. If I want to figure it out the moles, I need to use the molar mass. Or if I want to figure it out how many particles or atoms I actually have in a specific amount of grams, I can use the Avogadro's number, which is 6.022 times 10 to the 23rd. Okay, knowing how to use this make my calculation a lot more simple. So here, the problem asks how many atoms I have in 0.5H3 of Mg. So I know the problem gave me the mass. So I'm here, and the problem asks me how many atoms. So they want to know how many particles or atoms. So it says goes from mass to particles. In order to get there, I know that I needed to use my molar mass and convert everything to moles. And I know that I needed to use an Avogadro's number. So let's run this calculation really quick. So I have here, was given to me 0.5H3 grams of Mg. And I say, well, I need first to find how many moles are equivalent to 0.5H3. So my first step, I will call here step number 1, is find the moles. I have grams in the top, and I will use my molar mass. I know that grams in the top, I need to have grams in the bottom. So grams and grams can cancel out. And I needed to have moles in the top. So grams and grams can cancel, and I ended up having moles. Now, I know that 1 mole has how many grams of Mg, magnesium. I look at my periodic table, and I know that 24.3050 grams of Mg is equivalent to 1 mole of Mg. It's just the molar mass, straightforward. The next step, I will call step number 2, is figure it out how many particles or how many atoms. And we have a relationship. 1 mole, and now this time I put moles in the bottom because I can cancel moles and moles. I call 1 mole. It's equivalent to 6.022 times 10 to the 23rd atoms of Mg. Now, I know that grams cancel with grams, moles cancel with moles, and I ended up with atoms of Mg. So if I do 0.5H3 times 1 times 6.022 times 10 to the 23rd divided by, in your calculator you want to use parentheses for the numerator, 24.3050 times 1. I get my answer. I already did that in my calculator, and this is equivalent to 1.44 times 10 to the 22 atoms of Mg. Again, the question gives me grams, asks me for how many atoms I have there. So I know that I'm here in my molar map, in the mass. In order to find how many particles or atoms, I need first to find the moles. This is what I did in my step 1. I use my molar mass on here. And then the step number 2, I need to convert moles to particles or atoms. And in order to do that, I use my Avogadro's number. So grams and grams cancel, moles and moles cancel. I ended up with this, grams times 1 times the Avogadro's number, divided by 24.3050, and I and plugging everything in my calculator gives me that answer. So problem 1 is solved. So we understand now how to calculate how many atoms I have using the grams. Now, in problem number 2, says which simple has more atoms? 16.32 grams of sulfur or 12.93 grams of oxygen. Basically, we're doing a comparison. So again, I needed to look at my molar map and say where am I and where I'm going. If it gives me grams, I know that I'm here. And I want to know how many, what one of these two has more atoms. So I'm going here again, okay? So let's do the calculation one more time. And I actually don't have an eraser here. So I do this in a fast way. And I would say if you, you can stop the video now, do it by yourself, and then check if you got the same answer that I got it. So I'm here in mass. So I start with sulfur. I have 16.32 grams of sulfur. And I go from grams to moles. So I know that grams needs to be in the bottom and moles in the top. I look my periodic table, and I know that the mass is 32.065. Okay. And then I place the moles in the bottom because the moles is in the numerator here, so it goes to the denominator, so we can cancel them out. And Avogadro's number. And then I do the same thing for oxygen. Oxygen would be 12.93. And then I go from grams to moles. And on here would be 15.9994 grams of oxygen. And then I need to find how many atoms. So step number 1, step number 2. Step number 1, step number 2. And that's my final answer. I already did that calculation. This would be 3.06 times 10 to the 23rd atoms of sulfur. And 4.55 times 10 to the 23rd atoms of oxygen. Therefore, I know that 12.93 grams of oxygen has more atoms than 16.32 grams of sulfur. So this guy has more atoms. So again, just as a review, if we're finding how many atoms using the grams, I look at my molar map, I say, well, I'm here and I'm going here, and I just follow what is given there. So in order to find the atoms, I needed to first find the moles. This is what we did in the first step here. And from the moles, we find the particles or atoms. The same thing for the other one. And then we compare our answer.